Water conservation is crucial for sustainable water management, especially in regions facing water scarcity. Key strategies include the development of watersheds, rainwater harvesting, and groundwater recharge. Development of watersheds. A watershed is an area of land that drains all precipitation to a common outlet such as a river, bay, or lake. The objectives are to manage and conserve water resources, reduce soil erosion, enhance agricultural productivity, and improve the livelihoods of communities. Key practices include soil and water conservation, such as implementing contour ploughing, terracing, and check dams to prevent soil erosion and retain water. Afforestation and reforestation involve planting trees and vegetation to stabilize soil and enhance water infiltration. Water harvesting structures like small dams, ponds, and tanks capture and store rainwater. Community participation is essential, involving local communities in planning and maintaining watershed projects to ensure sustainability. The benefits of these practices are increased water availability for agriculture and domestic use, improved groundwater levels, enhanced biodiversity and ecosystem health, and reduced vulnerability to droughts and floods. Rainwater harvesting. Rainwater harvesting involves collecting and storing rainwater for reuse rather than letting it run off. The objectives are to augment water supply, reduce dependency on groundwater and surface water sources, and mitigate urban flooding. There are different types of rainwater harvesting. Rooftop rainwater harvesting captures rainwater from rooftops and stores it in tanks or directs it to recharge pits. Surface runoff harvesting collects rainwater from open spaces, roads and fields into reservoirs or recharge structures. Key components of rainwater harvesting systems include the catchment area, which is the surface that receives rainfall and directs it to the storage system. Gutters and downspouts are channels that convey rainwater from the catchment area to the storage or recharge system. Storage tanks are containers to store harvested rainwater for later use, and recharge pits or trenches facilitate the infiltration of harvested rainwater into the groundwater aquifer. The benefits of rainwater harvesting are that it provides a supplementary water source, reduces water bills, and conserves municipal water supply. It helps manage stormwater and reduce urban flooding and enhances groundwater recharge, mitigating the effects of drought. Groundwater recharge is the process of replenishing underground aquifers with surface water, typically rainwater. The objectives are clear: to increase groundwater levels, sustain groundwater supplies for irrigation, drinking, and industrial use, and to prevent land subsidence and saltwater intrusion. There are several methods of groundwater recharge. Recharge pits or trenches are shallow excavations filled with permeable materials to facilitate water percolation. Recharge wells are deep wells designed to inject surface water directly into the groundwater aquifer. Percolation tanks are large tanks that hold water and allow it to slowly infiltrate into the ground. Check dams and nulla bunds are small barriers constructed across streams and rivulets to hold water and enhance infiltration. The benefits of groundwater recharge are numerous. It restores depleted groundwater levels, ensures a sustainable water supply for agriculture and domestic use, reduces the impact of droughts by providing a reliable water source, and helps in maintaining the natural flow of rivers and streams. An integrated approach combines watershed management, rainwater harvesting, and groundwater recharge. Comprehensive planning involves developing integrated water resource management plans that include all these elements. Community involvement is crucial, engaging local communities in the design, implementation, and maintenance of water conservation projects. Policy support is also essential, implementing supportive policies and regulations that promote water conservation practices. And of course, technological innovation plays a significant role, adopting new technologies and practices to enhance the efficiency and effectiveness of water conservation measures. These strategies collectively help in conserving water, improving water availability, and ensuring sustainable water management for future generations.